Derivative method. The anti-derivative. The anti-derivative method. Okay. So this method is what? So this method. Okay. So for this method, we fix the left endpoint A and let the right endpoint bx. Okay, b sum x. So here it's easy to see that the area of under the curve is dependent on the right endpoint. So the area actually is a function of x. So here the area actually is dependent on the right endpoint. So here and we have a conclusion that, so you are late again.
7 minutes left.
7 minutes. So the last class you are late 6 minutes.
Yes.
So this class.
Now day by day he is improving now, see.
Now we have 4
3 minutes.
No.
That's under 4, man.
We start now 4:10.
So here, the anti-derivative means that the derivative of this function, ax, a derivative, okay, equal to what? Equal to fx. This fx actually is this f, okay? This f. So from here we have that the area function ax actually is anti-derivative of f. So ax actually equal to what? Ax actually equal to the antiderivative of f. So the antiderivative, now we know that the antiderivative here we have a constant, yeah? Equal to some function plus a constant, yeah?
Yes.
So here we need to determine the c, okay? We determine the c. So here we need to determine ax means that because when x equal to a, actually we have the a, capital A equal to what? Equal to 0. So we use this formula. We use this formula to determine the constant c. So to determine the constant c, so here we have the ax. So from here we can determine the ax. So the area actually is the a area is the function at b, yeah. So a equal to ab, yeah. So this is the first method, okay. Means the anti-derivative method. And we introduce another method. Another method means that the mathematical method, okay? So the mathematical method. So mathematical method, okay? So the mathematical method, how to do? So the mathematical method actually is we introduce the first. We have 3 steps. So here for the rectangle method, actually we use some rectangle to approximate the area of some rectangle to approximate the area of A. Yeah. So here, so now we need to, here is B, here is B, here is A. So now we need to find the area A. So how to do it? So the rectangle method actually is we use many rectangles to approximate the area of A. Yeah. So this is the key point. So we have 3 steps. The first step is we divided we divided the interval AB to many sub-intervals. So here we have the first step. Step one is now we divided AB, divided the interval, okay, divided the interval into n equal sub-intervals. So here, the first step is we divided AB into n equal sub-intervals. For example, here is x1, here is x2. So go on. Here is xn minus 1. So here this is from here we have that the each sub-intervals has the y's delta x. Delta x equal to what? Delta x equal to the length. Okay, the length actually is the right endpoint minus the left endpoint. This is the length. Yeah. So b minus a. This is the total length. So we divided the total length into n parts. Yeah. N equal parts. So here, so the y's of the each sub-intervals actually is b minus a divided n. Yeah. So this is the y's. Okay. This is the y's of each sub-interval. And this is the first step. Okay. This is the first step. So here for convenience. Okay. So convenience we denote the a actually x0. So here. So now we find the point, okay? The left point we let it to x0 equal to a, okay? x0. We denote the left endpoint is x0. So the second, the x1 is here, x1. So x1, what's the relationship between x1 and a?
x1 minus a.
So here this length, okay? So this length is what? This length actually is the length of the y's of the sub-interval, yeah? So here actually x1 equal to a plus delta x, yeah? So x1 actually equal to what? Equal to a plus delta x. A actually is x0. So here actually we can divide the x0 plus delta x. So this is the first point x1. So what about x2? So actually x2 this length is delta x, so the length of x2 and a is what? Is 2 delta x, yeah? So actually x2 equal to what? x2 actually equal to a plus 2 delta x, yeah? So here the second point is x2 equal to a plus 2 delta x. We can divide it in x0 plus 2 delta x. So here, it's easy to see, okay? Here is x1, so here is 1. Here is x2, so here is 2. So here we can go on, so we can actually xk equal to what? Xk equal to a plus how many delta x? K, yeah? So k delta x, so here actually is x0 plus k delta x. So go on, go on the last, okay, the right endpoint, B. So the right endpoint we denote by xn equal to what? Equal to B, okay? So here we sum, the first step is we divide the interval AB into n equal some intervals. So, and we find some point. Okay, this is the first step. So the second step, the step two is we need to construct the rectangles. So here, the second step is over each subinterval. Over each subinterval, we construct a rectangle whose height is the view of f. The view of f at an arbitrary selected point in the subinterval. So here the second step is we over each subinterval, okay, we need to construct a rectangle whose height. Now here whose height is the view of f at an arbitrary selected point in the subinterval. So here means what? Here means that in the first subinterval, okay, we use this as the y's. So the height is what? So the height is which first we choose a point in this subinterval. This point can be the left endpoint, or the right endpoint, or the midpoint, or other point. Okay. So here in this subinterval, we choose a point. This point we denote by x1 star. Okay, x1 star. So here we use the view of f and the x1 star as the height. So the height. So here the first rectangle. The y is delta x. The height is what? The height actually is f x1 star. Okay. So here this is the first rectangle. Okay. So here now we have the first rectangle. The area of the first rectangle is what? The area of the first rectangle actually is delta x. This is the y's. Okay. This is the y's. So and the length of the height is f x1 star. This is the height. Okay. This is the height. So the y is what? The y is delta x. So this is the area. This is the area of the first rectangle. Okay. The first rectangle. So now do it again. Okay. So do it in the second subinterval. Okay. So the second subinterval the same. Okay. First we choose a point. At the second subinterval. So here we choose a point for here. For example, here is x2 star. Okay, x2 star. Here x2 star is belongs to the second subinterval. Okay, this point can be the left point, the left endpoint x1, can be the right endpoint, x2, or can be the midpoint of this subinterval, or be any other point, okay? Or be any other point on this interval. So here, the second rectangle is use the function value at this point, at the height. So here, this is the height. This is the height, and this is the y. So this here is the second sum of the second. This part is the second rectangle. Okay, this is the second rectangle. So here the area of the second rectangle is actually f x2 star times delta x. Okay, times delta x. So this is the area. This is the area of the second rectangle, okay? The second rectangle. So we do it again and again, okay? So at the last one, at the last subinterval, so for the same, okay? We choose a point. This point we denote it by xn star, okay? And we use f xn star as the height, and delta x as the y. We construct a rectangle. Okay, we construct a rectangle. So the last rectangle is like this. So the last one rectangle area actually is fxn star times delta x. Okay, times delta x. So here, the first, the second, and the third, the fourth, the last one. Okay. So here now we use the sum of all rectangles. Okay. We use the sum of all rectangles. We use the sum of the area of all rectangles to approximate the area of A. Okay. So here we plus. This is the total area of all rectangles. The total area of all rectangles. So here, this we give it a rotation an. Okay, an. This an. Okay, we give it a rotation an. This an actually means the total area of n rectangles. Okay, n rectangles. So here, actually we can rewrite this part. Use the sigma rotation. Okay. So here actually equal to the sigma f1 star or fk star times delta x. Here k runs from 1 to n. Okay, k runs from 1 to n. So here we can write the sum and use the summation notation. Okay, summation notation. So here is an. So here at the second, okay, at the step 2, here I want to say that the x n star, okay, x1 star, x2 star, xn star. This point, okay, is any point on the subinterval. Okay, this point can be the left endpoint of each subinterval, can be the right endpoint of each subinterval, or can be the midpoint. Okay, or can be the any other point. Okay. So here, this is the second step. Okay. So now for the step 3, is step 3 actually is repeat the process. Repeat the process, using more and more subdivisions, okay? Subdivision. And define the area A equal to what? The area A equal to limit n approaches plus infinity an, okay, an. So here means that the A actually is the limit of an, okay? Here an is the total area of n's rectangles, okay?
Yes.
So here an, the formula of an is like this. So here actually equal to limit n approaches plus infinity. Here sigma f k star times delta x. K runs from 1 to n. Okay, k runs from 1 to n. So here this limit, okay, this limit of an, okay. So here the limit of an is no matter, okay, is no matter how the sk star is chosen, okay, is chosen. So here, the limit of an is no matter how the xk star is chosen, okay. So here means what? Here means that if I choose the xk star as the left endpoint, so here we have the limit, okay. So for example, if we choose xk star as the left endpoint, or the right endpoint, or the middle point, or any other point, they have the same limit, okay? They have the same limit, okay? So the meaning of this sentence is we choose xk star as the left endpoint, or the right endpoint, or middle point, or any other point in the subinterval. The limit of an is the same, okay? It's the same. So here, now, okay. Now let's see the process. Let's see the process on PPT, okay? So the first step is divided the interval AB into n equal subintervals by inserting n minus 1 equally spaced points between A and B, okay? And denote these points by x1, x2, xn minus 1, okay? So here this finger, okay, this finger here, this is AB, so we divided into n equal subintervals. So and the point is x1, x2, xn minus 1, okay? So for this subintervals, okay, so the width of the subintervals is delta x equal to b minus a divided n, okay? B minus a divided n. So this is the first step. So the second step is over each subinterval, okay? Over each subinterval, we construct a rectangle whose height is the view of f at an arbitrarily selected point in the subinterval. So here, this point we denoted by x1 star, x2 star, xn star, okay? So denote the points selected in the subintervals. Then the rectangle will have the height fx1 star, fx2 star, go on fxn star, okay? So the areas, so here, for example, x1 star we choose at here, x2 star we choose here, x3 star we choose here, so go on, okay? Go on. So the area of the first rectangle actually is fx1 star times delta x. The area of the second The area of the second rectangle actually is fx2 star times the length. So the area of the last one rectangle actually is fxn star times the length. Okay. And the union and the step 3 is the union of the rectangles forms a region Rn. Okay, whose area can be regarded as approximation to the area A. Okay, the area A. So here means that the area A actually is approximately equal to the area Rn. Okay, so here we have that A actually equal to the sigma k equal to 1 to n fxk star times the length. So this is the second step. So the third step is repeat the process using more and more subdivision and define the area of R. Define the area of R to the limit of the areas of the approximating region Rn. Okay, as n increases without bound. That is, we define the area A equal to the limit n approaches plus infinity, the sum of fxk star times the length, while k runs from 1 to n. Okay.
Yes.
So from this process, we have the definition. The definition: area under a curve. If the function f is continuous on the closed interval AB, and if fx greater than 0, greater than or equal to 0 for all x in AB, then the area A under the curve, okay, the area A under the curve y equal to fx over the interval AB is defined by A equal to the limit n approaches plus infinity sigma k from 1 to n fx k star times the length. Okay.
Yes.
So here give us a method to find the area. Okay, find the area actually is you first use n rectangles to approximate the area, and then to compute the total area of the n rectangles, and then find the limit. Okay, find the limit. So here, this is the first definition. Now let's give an example. So here, now let's see the example. So you switch the here, you are late. Okay? So, for example 1, use definition with xk star at the left right endpoint and the midpoint of each subinterval. Each subinterval to find the area between fx equal to x squared and the interval and the 0 to 1, the closed interval. Okay. So actually, it's the area. We plot the graph. Here is 1, here is 0, here is 0, here is x, here is y. So this curve is y equal to x squared. Y equal to x squared. So the first step is you need to divide the closed interval into n equal subintervals. So here now step one divided, yeah. So divided here. Divided, for example, here is the x1, here is the x2. So go on. Here is the xn minus 1. So here this step we divided it into n subintervals. So here divided the interval from 0 to 1, okay, into n equal subintervals. So here in this step, so we can find that the y's of each subintervals is what? Is delta x actually equal to what? Equal to the total length of the subinterval 1 minus 0 divided what? Divided n, yeah? Divided n. So this is 1 by n, okay? 1 by n is the y's of each subinterval, okay? The y's of each subinterval. So here is delta x. So and now let's see here the left endpoint we denoted by x0. So x0 equal to 0. x1 equal to what? x1 equal to what? x1 here. x1, okay. x1 actually equal to 0 plus delta x. Yeah. So here is delta x. x1 equal to 0 plus 1 delta x. x2 equal to what? x2 equal to here is delta x. So here this actually is 2 delta x. Yeah. So here x2 equal to 2 delta x. So go on. We have that xk actually is k delta x. Yeah. So go on. Here we have the last xn actually is the right endpoint 1. Okay, right endpoint 1. So in this interval, so here we have that the subinterval actually is what? Is the first interval is x0, x1. Yeah. So this is the first subinterval. Yeah.
Yes.
The second subinterval is what? The second subinterval actually is x1, x2. Yeah. This is the second subinterval. Yeah. So the third subinterval is what? Is x2, x3. Yeah. x2, x3. Yeah. So go on. The last one, the n subinterval is what? actually is xn minus 1 xn, yeah? So this is the n subintervals, okay? N subintervals, this is the first step. So the second step, so the step 2, is now we need to construct the rectangles, yeah? So the rectangles here, now we use xk star, we choose xk star as the left endpoint. So the first, okay, we use the left endpoint. So the left endpoint, the left endpoint of each subinterval. So no, I'm sorry here. The second is with the an actually is what? The an so here the rectangle of we choose 1 star, and this is the first subinterval, and we use it as the height times the y's. So this is the area. This is the area of the first rectangle. So and the second rectangle, fx2 star times delta x. Yeah. So this is the area of the second rectangle. So go on. The last one. So the last one is what? Fn star times delta x. Yeah. So this is what? This is the total area of n rectangles. So we divide it by an. So this is an, okay? So now here we choose x1, or we choose xk star as the left endpoint. So here the first, so xk star as what? As the left endpoint. The left endpoint of what? Of each subinterval. So here, we choose xk star as the left endpoint of each subinterval. So here means what? X1 star actually is equal to what? So we choose the left endpoint. So the left endpoint of the first subinterval is what? X0, yeah? So X1 star actually is X0, yeah? So here actually is the first is X0 times delta X. So here X2 star, okay? X2 star belongs to the second subinterval. So now we choose X2 star. We choose X2 star as the left endpoint. The left endpoint is what? X1, yeah? So here plus fx1, yeah, times delta x. So go on. So the last one, xn star. Xn star belongs to the last one subinterval. And we choose the left endpoint of the last subinterval. So here xn star is what? Xn minus 1, yeah? So here equal to xn minus 1 times delta x. So here is an, okay? Here is an. Now first, delta x, okay? Delta x actually is what? Delta x actually is a constant, 1 by n, yeah? So here we can take out delta x. So here is what? Here is fx0 plus fx1 plus fn minus 1, yeah? So we take out delta x, yeah? And x0 actually is what? So here equal to what? So delta x actually is 1 by n times fx0. fx0, here f is what? F is x squared, yeah? So x0 actually is what? x0 squared, yeah? So here actually is what? Here is actually is x0 squared. Here x1, okay? fx1, here is x0 squared. fx1 is what? Is x1 squared, yeah? So xn minus 1 actually is xn minus 1 squared, yeah? x0 equal to what? x0 equal to 0, yeah? So here actually is 0 squared plus x1 square, x1 actually is delta x. Yeah? So here is delta x actually is n minus 1 by n. So here actually is 1 by n square. Yeah? Plus what? xn minus 1 actually is what? xn minus 1, we know that xk equal to k times delta x. So xn minus 1 actually is what? Is n minus 1 times delta x. Yeah? Delta x is what? Delta x is 1 by n. So xn minus 1 actually is n minus 1 by n. Yeah? N minus 1 by n. So here is actually is n minus 1 by n square. Yeah? So here actually is 0 square plus 1 by n square plus n minus 1 by n square. Yeah? So actually it's this, okay? This. So here, no, we need to find this sum, okay? We need to find this sum. So here we open it. Actually here is what? Here is equal to 1 by n. So 0 square is 0. So 1 by n square actually is 1 square by n square, yeah? Plus the second actually is 2 by x square. 2 by n square. So here actually is 2 square by n square, yeah? 2 square by n square. So go on. The last one is what? Is n minus 1 square by n square, yeah? So here is like this, yeah? So here we can see the denominator actually is all is the same, n square. So we take it out. Actually here is what? Is n square times n, so n cubed. So here is n cubed 1, or 1 by n cubed. Here is what? Is 1 square plus 2 square plus n minus 1 square, okay? So 1 square plus 2 square plus n square, n minus 1 square, this equal to what? So here's the way. So you stand up and answer me. Yes, stand up. You, yeah? So answer me. 1 square plus 2 square plus n square equal to what? I introduced the result in the last class. So this equal to what? 2n square. So you here is empty. So you, yeah. Stand up and answer me. So 1 square plus 2 square plus n square equal to what? So you here is also empty. So you, yes, stand up.
Is n minus 1.
N minus 1. What?
Is n
Minus or n times?
n times 1.
N times 1. And what? Divided 6. Yeah, it's this one. So you can see n equal to 1. So 1 equal to 1 by 6. So, we empty here. So, who knows? Who knows? Yes?
Is n times
What?
N into n plus
And what?
n into n plus 1
Yeah, n plus 1
divided 2.
divided 2.
Yes,
Divided 6.
divided 2.
Divided 2. So now you answer me another question. 1 plus 2 plus n equal to what?
N plus 1, 2n plus 1. N
So sit down, sit down. So who knows? So you.
n
Here is what?
n open bracket n plus 1 close bracket open bracket 2n plus 1 over 6.
Yeah, this is one. So what about this one?
n plus 1 over 2.
Yeah. So here we use the first formula. So we use the formula here. 1 plus 2, 1 square plus 2 square plus n minus 1 square equal to what? This actually is what? This actually equal to 1 by n cube. Here is, we replace this n by what? By n minus 1, yeah? So here it should be n minus 1 times n minus 1 plus 1. So here is n times what? 2 times n minus 1 plus 1. So here is 2n minus 1. So here is 6. So here, okay. So here we can open it. So here is n cube. Here is n. So we cancel 1n. We cancel 1n. So here is n square. So here is 6n square. So we open it. Open the bracket. So here is what? Here is 2n square. 2n square minus 3n plus 1 divided 6n square. So when n go to plus infinity, this go to what? This approaches 2 by 6. Yeah? When n approaches plus infinity, this go to 2 by 6. So it's 1 by 3. Yeah? So here this approaches what? Approaches 1 by 3. Yeah? So here means that if we use the left endpoint as the xk star, so the limit of the total n rectangle area is 1 by 3. Okay, 1 by 3.
Let's repeat again
Here,
how that was
here, here actually,
from
here to here.
because one over n cube.
Here is so you open it, so n times 2n minus plus n times minus 1 plus minus 1 times 2n plus minus 1 times minus 1. So here this is the result, 2n square minus 3n plus 1. Okay?
And then 6n squared, we have the 1 over n cube.
Here. So here, so you that n equal to plus infinity. So actually you can divide it n square on both sides. You divided n square on both sides. So here is 2. 2n square divided n square. So it's 2 minus 3n divided n square is 3 divided n plus 1 by n square divided 6n square divided n square. So here is 6. When n go to plus infinity, this part go to 0, this part go to 0, so actually this part go to 2 by 6. Yeah? So now, here, this is we use the left endpoint. Okay, the left endpoint. Now, if we use the right endpoint, here, if here is right endpoint, here means what? Here means that the x1 star takes what? X1 star takes the right endpoint of the first sum interval, yeah? So x1 star takes what? X1, yeah? So here actually is what? Here is x1 and x2 star. X2 star takes the right endpoint of the second interval, okay? So here, so x2 star takes x2, yeah? Takes x2, so here is x2. So go on. So here xn star takes the right endpoint of this sum interval. So xn star takes xn, yeah? So here is xn. So here is xn. So xn, so here is x1, here is x2, here is xn. So here, now we can see this part. So here, now if we use the x1, fx1 actually is x1 square plus here fx2 actually is x2 square plus fxn actually is xn square. Xn or x1 actually is what? X1 actually is delta x. So here delta x is 1 by n. So x1 square actually is 1 by n square. Yeah. x2 actually is 2 times delta x. 2 times delta x equal to 1 by n. So 2 times 1 by n actually is 2 by n. 2 by n square. So the second is 2 by n square. So plus the last one xn. Xn actually is 1. So here actually is 1 square. Actually 1 we can write it by n by n. So here actually is n by n square. So here actually is equal to 1 by n times 1 by n square plus 2 by n square plus n by n square. So this equal to here, yeah? So here 1 by n square actually is what? Is 1 square by n square plus 2 by n square actually is 2 square by n square. 2n square by n square plus the last one is n square by n square. So this n parts have the same denominator, yeah? So here we take out n square. So here actually is 1 by n square times n. So here is n cubed. So here is what? Here is 1 square plus 2 square plus n square. So here 1 square plus 2 square plus n square equal to what? Equal to here, yeah? So here we replace it by 1 by n cubed times n plus 1 times 2n plus 1 divided 6. So here we have n, here we have n cubed, here we cancel 1n, okay? We cancel 1n, so here is n square, and we open it, so here actually is what? It's 2n square, n times 2n, so 2n square, n times 1n, 1 times 2n, n plus 2n, so here is plus 3n, 1 times 1, so plus 1, divided 6n square, So here, now let's n go to plus infinity, we can see that this go to what? This go to 2 by 6, yeah? So the area is also 1 by 3, okay? So here now we can see if we take the left endpoint and the right endpoint, the limit is all 1 by 3, okay?
Yeah.
So hyperbolic.